We are going to see that logarithmic functions are simply the inverse of exponential functions. By the end of this video, you understand where logarithms come from, how to graph them, and why certain restrictions exist. Let's begin with our familiar exponential function, y equals b to the power of x. Now, if logarithmic functions are inverse functions, what do we do first? We switch x and y. Now our goal is to solve for y, but the variable is in the exponent here. Solving for a variable in the exponent directly is very difficult. So what can we do? This is exactly why logarithms were created. We take logarithms on both sides with base b. Log base b of b to the power of something simply gives us that something back. So the right side becomes y. So we discovered y equals log base b of x. That means logarithmic functions are the inverse of exponential functions. Now let's graph it. Inverse functions are reflections across the line y equals x. So let's start with the graph of an exponential function. Now imagine folding the graph along the line y equals x. The reflected graph becomes y equals log base b of x. So logarithmic functions are reflections of exponential functions across the line y equals x. Let's use the graph to understand domain and range. For exponential functions, x can be any real number, but the output y is always positive. So the range of an exponential function is y is greater than 0. For inverse functions, domain and range switch. So for logarithmic functions, the domain becomes x is greater than 0, and the range becomes all real numbers. That means you can never plug in 0, you can never plug in a negative number either. This is because an exponential function with a positive base never produces 0 or a negative output. Now what happens when x equals 1? Ask yourself, what exponent gives us 1? Any positive base raised to the power of 0 equals 1. So log base b of 1 equals 0. That means the graph always passes through 1, 0. The exponential graph passes through 0, 1. When we reflect across y equals x, the coordinate switch. So 0, 1 becomes 1, 0. There is one more thing. The base b must be positive. And b cannot equal 1. Y must be positive. Because in an exponential function, the exponent can be any real number. If the base were negative, certain exponent values would create expressions that are not real numbers. For example, negative numbers raised to the powers like 1/2 create problems in the real number system. Since we want the exponential function to be defined for all real values of x, the base must be positive. And y can't be equal 1 because 1 raised to any power is always 1. That means the function would always produce the same output. There would be no one-to-one relationship. And inverse functions require one-to-one functions. So for logarithmic functions, b must be greater than 0 and b cannot equal 1.